Hey, this is Henry, and welcome to today's tutorial. What we're going to be doing today is building an application that's going to mix our JWT authentication and authorization system with a PERN stack to-do list. And I thought this was a fantastic idea, and I have to give full credit to Compte Prive for suggesting it. And I even have the comment over there, and the highlighting is really bad, but essentially what was said is that it would have also been great to see how this worked with the existing to-do app you made. Like, how do you store to-dos by users, and how do you load the correct user to-dos once authenticated? Right? These are great questions because this gives me the opportunity to teach you guys two very important skills. Number one, which is learning how to build relationships with more than one table. So typically when you're watching tutorials, they're going to teach you how to work with one table. But that's great when it comes to learning basics, but typically when you move on to building more like advanced application, you're going to need to make more than one table and learn how to build a relationship with them. And the second thing I want to teach you guys is going to be database designs, right? So I'm going to teach you guys some of the basics of how to build tables, how to build relationships, and how we can use this to translate to building our application, right? All right, so I'm just going to go back inside here and just give you guys a quick demo. So we're going to be building this application as we're learning database designs and like relationships. So I'm just going to create a new user. And I am going to, you can see over here that I have my own dashboard with my own to-do list. And I added a few features, like if you have nothing, you can add anything. So if I add an H, or let's say hello world, and I click add, you're going to see that it doesn't refresh anymore. I can even edit the data, and it's still not going to refresh. So we're going to learn how to do those extra features. And of course, you can delete that. Now, if I decide to leave it over here and I log out to another user, let's see if it's truly private. So I'm going to write test number 2, and I'm going to write this as test 2, whatever, we'll keep it that way. And you can see here that we don't have the to-dos. So if I say goodbye, and I say hello, maybe it's a little better if I say hello-y, right? So it can be clearly different. So now if I log out and I go back to test@gmail.com, you're going to see that I continue to persist with my same data, my own private data. Right, so this is the application we're going to build, and we're going to learn database designs and relationships along the way. All right, so there is going to be some prerequisites to this thing. So this is going to be more geared for people who already have taken my tutorials over like the PERN stack to-do list and the JWT tutorials, right? Because it's going to be utilizing these same exact codes in order to build this application. There is just going to be a few changes. Like for example, in my GitHub repository, the PERN JWT tutorial is going to be my starter code, and I'm going to progressively take snippets from this code over here to this right here, right? Because the big picture is that I want to really teach you guys about database designs, right? I think database designs is probably one of the most important skills to learn when it comes to building any software application, because it determines your scalability, your security, your efficiency, and it makes you understand the overall architecture a lot more better. Right, so I want to give you guys that same exact experience. Okay, so now that that's all set up, in the next section, I'm going to give you guys a practical introduction into database designs. So I'll see you then. All right, so welcome to this practical introduction into database designs. All right, so the reason I call this practical is because it's not going to teach you everything about database designs, but enough in order to build this application, right? So just a little practical introduction. So besides that, let's just kind of go into this. What I first want you guys to do is go to this website called draw.io, because I want you guys to play around with the application. And it's totally free. You can use your Google account. And then you're going to be shown this page over here. So you're going to click on create new diagram. You can name this whatever you want. And then I want you guys to click on entity relationship diagram. Okay, so once you click on that, click create. Save it to wherever you want. You can save in the root folder, and then you're going to hit this section over here. All right, so this may look a little bit funky, but just have a really good look over it before we delete this. You can see over here that we have a table that's called customers, we have a table called orders, and a table called shipments. All right, and you can see over here that we have relationships between these things. And look at these things. We have something called PK, and we have something called foreign key. All right, so just kind of keep those things in mind. Don't worry if you don't understand this, because we're going to go over all of these things. All right, so you guys can delete this, or you guys can keep it as reference, do whatever you want with it. But I am going to give you guys a quick diagram or notes over some basic things. So what is an ERD diagram? So an ERD diagram is simply a diagram that shows entities in a database and the relationship that these entities have with each other. So this kind of begs the question of what exactly is an entity. An entity is simply a thing or it's an object that exists. And in many cases, it's simply a table. So if you remember, if we go back inside here, this is an ERD diagram. You can see that these are the tables and you can see the relationship built between them. So as an entity, it's going to have some attributes. So similarly, you know how attributes are just really just qualities. So things have qualities. So I went for an example like a person, which will be our entity. A person will have attributes like first name, last name, and age. So let's kind of go back to the definition. So what it's really saying is that an ERD diagram or ERD diagram is a diagram that shows tables in a database and the relationship that the tables have with each other. All right. So now that we clarify that thing, I'm going to show you guys a more tabular format. So it makes more sense in SQL terms. So we're going to go inside here to my Google spreadsheet. You don't need to make this. I just kind of made some sample data to make more sense. So you can see I have my person entity over here. And along with this, for each of my columns represents an attribute. We got first name, we have last name, and we also have age. And look at this carefully. You're going to notice that each row, in a way, represents a person. So this is a very important term that you're going to hear. But a row is called a tuple. And simply what that means is that it has all the attributes of that entity. So this is a person, this is a person, and this is a person, and so on, right? Okay, so this is nice and all. We know a little bit about entities and attributes. So let's kind of go down this data. You already saw Josh Jack, and then you saw Sally Dona, which is 15 years old. But then you'll see something called Josh Wang, which is 25 years old. Now this is a little bit strange because we also have a Josh, we also have a Wang, and we also have the same age of 25 years old. So there's absolutely no way to uniquely identify this Josh between this Josh. And that's a little bit problematic for us because if we're trying to build an application and we're trying to get a specific Josh, we don't know which one to pick. So what can we do in order to solve this problem? All right, so one solution we could do is create something that was known as a person ID. All right, so a person ID. So every time a new user is going to pop inside here, we are going to increase this by 1, by 2, 3, and 4. Okay, that's a little bit better because now I know this person ID 1 is correlated with this Josh, and this person ID number 4 is correlated with this Josh. Now, I'm able to easily distinguish between these other users inside the diagram, or inside this table. So what we just created was something that was known as a primary key. PK for short. So what exactly is a primary key? Right? I also want to tell you guys this up ahead, is that this is not the only way to create a primary key. But essentially, a primary key main purpose is to uniquely identify each records of a table. And you can see that I clearly did this in our case because this 1 now determines this is this Josh and this 4 is now correlated with this Josh. Right? So a primary key's main purpose is to distinguish each or uniquely distinguish each records inside a table. All right, so just remember that. There's another functionality, but we'll talk about that later when we get into foreign keys. All right, so this looks pretty nice. So if I go back into my diagram really quick, I just want you guys to get a little bit of practice. Okay, so as you can see over here, I have my person table, and along with that, I have my person ID with my PK. So that's my primary key, and I have my first name, last name, age attributes as well. So what you guys can do is go back to your little diagram, just kind of go down, and you're going to see something that's known as entity relations. So you're going to click downwards, and you're going to see all these neat tools that you can utilize. So what you guys are going to use is something called table1. You can just drag that really quick. And since we're actually trying to make an exact duplicate of this table over here, what we're going to do is we can change the entity. So I can name this thing as person. And then inside here, I can simply call this person ID. And just to keep it consistent, I'm going to get rid of the bold. And I'm also going to get rid of the underline. And of course, you can change this, but in the meantime, this is genuinely our primary key. And then this thing is going to be changed into our names. I want to make sure I got that correct. Our first name, last name, and age. All right, so let's do that really quick. So our first name and our last name, and finally our age. All right, so congratulations. Yeah, so that's what it takes to build a simple table, right? So you basically built an entity. right? So that's pretty neat. So let's kind of go back into this right here, right? So I just want to get you guys warmed up. Okay, so let's kind of go back to this Google spreadsheet. So what I mentioned was that this wasn't the only way to create a primary key, right? What we created was something that was known as a circuit key. Oh my god, what on earth is a circuit key? Sounds already weird, right? So a circuit key is whenever you're creating like an artificial attribute, so in this case person ID, and then you're simply generating value. That's what a circuit key's purpose is, right? That's the third way, or like out of the 3 ways to create a primary key. So if we go back inside here, before we talk about all the solutions, we need to know what makes a good primary key. So there's many ways or many qualities, but I just broke it down into 3 parts. Now remember, a main purpose of a primary key is to uniquely identify each record of a table. So look at these things. A primary key that's good can never change. It has to uniquely identify one row in the table, and it can't be null, it must always exist. Alright, so why can it never change? So the thing about it is that if I go back inside here, if a primary key has a possibility of changing, so let's say I accidentally change this to 1, right? The primary key changes. Well, now I'm screwed because now I'm back to, part 1 where I don't even know the difference between these Joshes anymore. And this will be a good example of a very bad primary key, right? It's not uniquely identifying each row of my table. Okay, so next one is, why does it have to uniquely identify one row in a table? Well, this one makes a little bit more sense because if we're trying to get something more specific, we're trying to update something, we're trying to delete something, we need to have something that's going to uniquely identify that table. And plus, we're going to start utilizing this primary key as a reference point for a foreign key so we can connect the 2 tables together, right? But we're going to talk about that later. And the next one is that a primary key can't be null. It just has to exist, okay? So just remember that. All right. So now that we kind of know the good qualities of a nice primary key, let's go along about 3 ways to actually creating primary key, right? So let me kind of shorten this a little bit so you guys can see all of it. So what's the 3 ways to create a primary key? There is a circuit key, there is a natural key, and there's a composite key. So circuit keys are the ones we worked with, and it's about generating value that's either going to be random or it's going to be increment. A natural key is not going to generate something value, it's not going to artificially create something. Rather, it's going to use attributes that already exist on our table. And then next we have composite keys, which goes good complementary with the natural keys, but it doesn't have to. A composite key is just simply combining more than one attributes together as the primary key. So let's talk about it. So I'm going to go back inside here, and let's look at this. This is an example of a primary key, right? I'm sorry. Oh my god, that's so obvious. Sorry, this is an example of a circuit key, right? Because what we're doing right over here is that we are generating values, right? We are artificially creating values in order to uniquely identify each records, right? So this is an example of an auto increment. So remember how I said this can be increment or it can be random. So our circuit key can either do UUID or it can utilize auto increment. So that's what we use right there. But what UUID is about being able to generate this really long string that's going to make sure that we don't have any duplicates within our application. So you know what, I'll just kind of pop that up really quick. Wikipedia is a nice one. All right, so let's go inside here and just talk about this. So UUID stands for Universally Unique Identifier. And I'll just bring you guys over here. And what you're going to see, you know what, I think it makes more sense if I show you guys what it looks like, because the way it looks like will explain it all. You can see that this is what's going to be generated, right? This really long, weird looking string, and it's going to be really hard for another one that's going to duplicate like this. So the chances of a collision or a duplicate, as you can see over here, so let's read this. The number of random version for UUIDs which needs to be generated in order to have a 50% probability of at least one collision is 2.71 quintillion computed as follows. That's crazy. That's a super, super low chance of getting duplicates. And one of the biggest reasons why people likes to use UUIDs. Right, so I can just take this really quick and just kind of give you guys an example. So I'll go inside here, I'll just steal this, and I'll just pop it inside here. So this is still a circuit key, right, because we're generating values, but in this case, it's not going to be incrementing, it's actually genuinely creating a random string. All right, so check this out. So of course, just imagine that all of these things are randoms, but you can see that this is what a UUID will look like on a table. All right, so cool. So now that we have that settled, let's talk a little bit about natural keys. So natural keys are basically using attributes that already exist. There's a reason why they're called natural keys, because they're not going to artificially create something like we did with the circuit keys. Instead, we're going to be using what we have right in front of us. So I'm going to copy this really quick, and I'm just going to paste it right here. All right, so let's look at this. So we're going to get rid of this thing over here. So these attributes over here, like first name, last name, and age, are really bad examples of what a natural key can be, right? They're not good primary keys because they're not going to uniquely identify each record, right? Because there can be a duplicate. Like there could be another person named Josh, there could be another person named Wang, there can be another person with the age of 25, as you clearly saw over this situation. So a good natural key that a lot of people like using is something that's known as a social security number. Right, we're not randomly generating this. This is data that's coming from the user. So social security number would be a good example. The reason for that is because everyone's social security number is going to be different. But I'm also going to give you guys a little heads up of why it may be a little bit problematic to use natural keys. Just in my opinion, but of course, always kind of divert your ideas to a lot more other people. So anyway, I'm just going to fill this out really quick. Okay, there we go. And finally right here. All right, we're on a row. Okay, so as you can see over here, this would be a good example of a primary key, and more specifically, a natural key. Okay, so look at this, circuit key, randomly generated. A natural key is like not going to generate a new value, rather it's going to use something that's already on the table. It's going to use data that has real meaning. So it's going to use social security number. Now, the reason why I don't think using natural keys, or in this case, social security number, is not the best idea as a primary key is because we have to keep in mind that natural keys' biggest benefits is about meaning, right? But the thing is that meaning is consistently changing, and there's always room for human error, right? So there's some things that might change for your business rules. And remember, one of the biggest things about primary keys is that they can never change. And by doing so, if they change, it's going to ruin the relationships with other tables. All right, so here comes composite keys, which are the ones that are going to complement natural keys. At least that's by my experience with it. So if I paste this down here, you're going to see that we still continue to have our natural key as our primary key, but the idea of composite keys, remember, and just kind of listen to it. It says composite keys. So if you know composite, it's about combining more than one thing together. So it's combining more than one attributes together in this case. So instead of just simply using the social security number as the primary key single-handedly, I want to combine more than one thing together. So for example, let's say we want to combine, I don't know, like an email. So let me just kind of put someone's email over here, and I'll just say j@gmail.com, right? So just imagine I filled all of these things up. But essentially, instead of utilizing just one natural key as the primary key, we can actually use composite keys, which we combine more than one attribute together to formulate that primary key. So now I can simply say, well, I want this thing to be the primary key as well. So PK. And then this will now be called a composite natural key. Sorry, a composite key. Let's just keep it that way for simplicity, right? And now this will be, so let me just get rid of this. So now this is going to be considered a composite primary key. So that's what people like to use. All right, so let's kind of review this really quick. So again, a circuit key is about generating values artificially to distinguish each record in the table. And then we have these natural keys, which is like, hey, no, I don't want to randomly generate something. Instead, I just want to work with things that are already on the tables, like social security numbers. And then composite keys are the idea of combining more than one attribute together in order to create that primary key. And typically, when you're working with natural keys, it's a good idea to utilize composite keys, all right? So just keep those things in mind. All right, so let's see what else. I hope I'm not missing anything. Besides that, remember how I said that this could potentially be a primary key, and this one could be a primary key, and these two could be primary keys. Whenever we have multiple occasions where things could be primary keys, we call these things as candidate keys. And candidate keys are a set of attributes or attribute that could qualify as the primary key. Right? It's almost like a presidency where we have multiple candidates and we are still yet to choose which one is the best one. Right? So those are the main keys that you're going to be looking at. All right, so hopefully that clarifies a few things about how to create a primary key and how to be able to pick the best way, or basically picking a primary key that's going to best fit your needs, right? Because the thing about database designs is that it's kind of really based on what you want to do. All right. So besides that, the next thing we're going to do is just have a little bit of practice over what we talked about. So we're going to go over to page 2, and you guys don't have this, but I just want you guys to practice with this. Oh no, let's get rid of this. Okay, I kind of gave you guys the answer, but what I want you guys to do is basically, I want you guys to build 2 entities, which is going to be called users and to-dos. And I want you guys to put all the attribute downs. So this is kind of the main reason why I want you guys to like work with the previous 2 tutorials, like the PERN stack do and the JWT tutorials, because you guys remember us building that database attributes. So I want you guys to build 2 entities. So I'll just give you guys a heads up. So 2 entities over here. And then I want you guys to basically put all the attributes for users and to-dos. And don't worry too much about the relationships, because we're going to be talking about that next. Okay, so yeah, I'll give you guys the solution in the next section. All right, so I hope that was a good exercise. So now we're going to provide the solution of the entity's name and also the attributes. So inside here, we have a user table and we also have a to-dos table. So if you guys remember correctly, whenever we created the JWT application, including the PERN stack to-do, in the PERN stack to-do, we had to create a to-dos table. And inside the JWT application, we had to create a users table. Okay, so to combine these, you can see in the user table, what we have as attributes are user ID, username, user email, and user password. And user ID is our primary key. And you can see over here that this is a UUID, and this is our surrogate key. All right. Hopefully that kind of starts putting things together. So inside here, I'm just going to simply, whoa, I don't know what I did. Okay, so I'm going to go inside here. I'm going to call this users, and I'm going to call this user ID. And I'm just going to keep this consistent. All right, and then the other attributes that we had was username. We also had a user email. And then we finally had a user password. All right, cool beans. Yeah, so we already created 1 attribute, so that wasn't too bad. And now we're going to work on this one. So our primary key for the to-dos table was simply to-do ID, and then we had a simple description. All right, so you don't have to worry about this user ID for now, right? This is going to be our foreign key. So if you guys want to get like a little bit idea of what's going to happen, this thing right here is going to connect to this UUID over there, right? So just a little heads up, but like again, we're going to talk about that in the next section. So we just have to focus on to-do ID and description. So our primary key was the to-do ID. It's that simple. Now you may start to notice that I pluralize my tables, right? I use users, I use to-dos. It's very important in name conventions to keep yourself consistent. If you decide to keep your tables like singular, then keep everything singular. If you decide to keep it pluralized, then keep it all pluralized. It'll just make things a lot more organized. All right, so now that I'm inside here, I'm going to delete these things. And the last one I have is just a simple description. Wow, okay, look at that. So we're all good. Yeah, that's all it really took to build our 2 entities. So in the next section, we're going to learn about the concept of crowfoot notation to start building relationship between our tables and start touching base on this concept of foreign keys. So I'll see you guys then. All right, so we have our users table and we also have our to-dos table, but yet we still don't have any relationship. So it all starts with something known as the foreign key, and I'll talk about this. But right here, what I have is just sample data. I have a user table. I also have a to-dos table. I even specify all the attributes that we have over here. All right, so inside here, you're going to notice that we have some fake people. So like Josh88, Tennyman, #6, Sellybelly, and so on. So let's say, for example, that Josh88 was the one that said hello world. And then Sellybelly was the one that said goodbye world. So how can we correlate this user table with the to-dos table? As you can see here, I have a empty little row, or sorry, this empty column that's ready to be utilized. So one of the things we're going to do is that I can specify user ID. So I can put this over here. So I'm pointing at here. And then since Josh88 was the one that said hello world, I could simply take their primary key, so in this case, this user ID, spit it over here. And since Sellybelly was the one that said goodbye world, I could simply steal this data, put it over here, and voila. Look at that. Now we started building relationships between these two tables. So what we just created was something that was known as a foreign key, right? So a foreign key is an attribute or column that refers to the primary key of another table. And by doing so, it's going to use that to link together the tables. Right, so the next question you guys might be thinking is a more technical one, whereas how we're going to be able to connect them. And just a little heads up, we're going to be using something called join operator, which I will talk about really soon. But besides that, you can start to see that we're building relationships with these tables. So how can we display this in a database design? So inside here, you're going to see that in the entities relations, we have something that's known as a, so we could just pick one of these rows over here, but I'm going to pick row number 3, and I'm just going to put this right under here. And you can see that we can just pop a row easily. In this case, remember, this thing was called user ID, and it is going to be our foreign key. So FK is for foreign key. So inside here, I'm going to define this as user ID, and guess it, it is going to be FK. Awesome. So yeah, there you go. So we have two tables, and now we specify the foreign keys and how they're going to connect with each other. All right, so hopefully that makes a little bit more sense. We don't really have any relationship lines between these tables quite yet, but that's why we're going to go on to talking about crowfoot notation. Okay, so I'll see you guys in the next section, and we're going to talk about this Egyptian tablet. So I'll see you guys then. All right, so we're almost done. You can see here that we have our entities, we have our attributes, we define our primary key and foreign key. Now the only thing that's going to be left is defining the line and the relationship between these two tables. So before we do that, we need to learn something known as crowfoot notation. Right? So remember I said it's like the Egyptian tablet, it looks complex, but it's not as bad as you think it is. Now the reason why it's called crowfoot notation is because literally it looks like a crow's foot. All right, so the thing is that it makes a lot more sense when I show you guys some examples. But what I want you guys to see is that these little keys over there, you're going to see that at the endpoints of each of these lines are going to represent these things. Okay, so let's go over these things. So this one represents one mandatory. This one stands for many mandatory. This one is one optional. And this one right here is many optional. Okay, so what on earth does that mean? Right, so it's confusing, but I'll show you guys this. So in this case, we have a one-to-one mandatory. You can see over here that these have the two solid lines like this one over there. So this one's a mandatory and the other one's one mandatory as well. Okay, so we have an employee and we have a contracts table. Now the thing is that in order for an employee to really be an employee, it must sign a single contract. And in order for a contract to exist, it must be signed by an employee. So they're tied together, right? It's mandatory for them to be connected to each other in order for their existence. So an employee must have only one contract, and a contract must have only one employee. All right, so hopefully that makes a little bit more sense. It still may be a little bit confusing, but as we go down, it'll make more sense. Now we have a one-to-one optional. So what on earth does that mean? So this is a one-to-many, a one mandatory over there. You see that, the two solid lines. And this one here is actually a one optional because it has that little circle over there. So we have a users table and we have a driver's license. So if you know things about driver's license, you don't have to have it, but if you do decide to get a driver's license, you can only have one per user. So that's why this user has this little relationship representing that it can have a driver's license, but if it does decide to have one, it can only have one. But if we switch that around, a driver's license must, and I mean must, have a user to exist. So that's why we have in this case a one-to mandatory. So I should have placed that down there, but I just wanted to focus more on optional in this case. So a user can have only one driver license, and a driver license must, that's the key word over there, have only one user. All right, so let's go down to the most common relationship, which is one-to-many mandatory. So the thing about this is that we have a mother's table and we have a kids table. So the thing is that in order for a mother to become a mother, it must have at least one or more kids. So that's why we specify this as mandatory, right? It needs to have one or more kids in order to be considered a mother. But if we switch that around for the kid situation, a kid must have only one mother, okay? So that's why these are one-to-many mandatory. So if you want to be more specific, one mandatory to many mandatory relationship. All right, so I think this is a perfect situation to talk about parent and child relationships, but basically whenever a foreign key is referencing a primary key from another table, the thing that's being referenced is considered the parent table, and the thing that's doing the referencing is considered to be the child's table, right? Just remember that, because people will sometimes talk about that. All right, so now we have a one-to-many optional. So what does this mean? So we have a users table and we have a cars table. So the thing is that a user can totally have no cars, but if they do decide, they can have more than one car. But when we look into the car perspective, a car doesn't necessarily need to have a user in order to exist, but it can have one in order to be driven. So a user can have 0 or more cars, but a car can have a user or 0 users, right? So that's why I left these things both optional. And now, if you look over here, we have a many-to-many relationship, right? This one looks a little bit funky. You can see over here that this is a many optional and this is a many mandatory. So we're talking about a student's table and a courses table. Now the thing is that in order for a student to be considered to be a student, it must take at least one or more courses, right? But for a course in its perspective, a course can be created, but it doesn't necessarily need to be taken by any students, but it can be taken by many students. Hence why I say it's a many optional. So a student must take one or more courses, and a course can be taken by 0 or more students. All right, so hopefully that makes a little bit more sense. If it doesn't, that's perfectly okay. I am going to provide some articles that will really make it clarify of what I talked about. All right, so that's what we are going to talk about. This is Crowfoot notation. Now, to really make sure you guys get this in your mind, I want you guys to do a little exercise. So based on the table over here that we have here, what is the best relationship between the users and the to-dos table, right? Just kind of go down the path that I talked about, like must have only one or must only one. Just talk about the relationship and it should make a little bit more sense. But like I said again, the relationships or the solution is going to come in the next section. But what I want you guys to do is go inside here to the entities relations and just kind of play around with the different relationships and kind of talk about it, see which one makes more sense. Right, so just for example, you're going to need to connect it to the primary key to the foreign key, right? Because that's how the connections is going to happen. All right, so in the next section, I'm going to give you guys the solution and break down how I solve it. So I'll see you then. All right, so we're going to go through the solution for this problem. So some of you guys might think this exercise was extremely easy, and that's awesome. But for some of you guys might think that this was quite challenging, and that's perfectly okay. Right? Database design is really this abstract thing, and it really takes some time to really kind of click it in. Like personally for me, it took me a long time to really get into database designs. All right, so here's some of the strategies I like to do when I'm ever facing some problems between relationships. So I like to draw a lot of pictures. So in this case, I have a picture over here, which is this actor with these other to-dos over here. So this actor, so this user over here, let me just change that to prevent confusion. Okay, so this is a user. So a user can actually make multiple to-dos. So a user can make this to-do, can make this one, can make this one. So it's a one-to-many relationship. Now the next question is whether or not it's optional. Okay, so we need to determine that really quick. Let's kind of get all these things really quick. Let's get all the one-to-many relationships. So this is one of them. Oh, you can even read it down here as well. It says one optional, many mandatory. So I'm going to grab these things really quick because these are the main ones we're working with. So now that we confirm this is a one-to-many relationship, I just got all the variations for them. Okay, so we're going to break this down like multiple choice. All right, so right now, does a user have to, or how about this? Does a user have to rely on to-dos to exist? So in this case, remember when our users logged into our applications, they didn't even need to have a to-do. But afterwards, they could totally write 0 or many to-dos. Right, so in this case, you can see that this is actually optional. This to-do over here is optional. So in this case, we don't need these things because it's not mandatory to make a to-do. Okay, so now that we have these optionals, now comes these lines over here. So can a to-do exist without a user? In this case, no. A user actually, or a to-do actually needs a user in order to exist. So it's mandatory that they're connected to each other. So in this case, you can see that a user is not optional. In fact, is actually quite mandatory. So we're going to get rid of this one right here. And look at that. This right here is our relationship. And I'll explain a little bit more. So I'm going to connect it to my foreign key, or sorry, my primary key to my foreign key. All right, so let's explain this. So for a user, they can make an optional of 0 or many to-dos. But for to-dos, it needs to be connected to one user, right? It's not optional because a to-dos can't exist if it doesn't have a user. So awesome. Yeah, there you go. Basically what we did here was a basic database design. So this is epic. Now we can utilize this as we build our application. Right, so now comes the more technical part. So now we're kind of leaning into part 2 where we're going to start actually programming this and learning more of the queries that needs to be utilized. So in this part, in the next section, we're going to talk a little bit about join operators. So we're going to talk about how we can combine these tables together in order to actually display them into the front end. All right, so I'll see you guys in the next section. All right, so we have completed our database design. So now time for us to go a little bit more technical and learn how we're able to join these tables together whenever they have a relationship. All right, so right here, if we go back inside here, we can clearly see that now that Josh88 has a relationship to Hello World, and we can see that Sally Belly has also a relationship to Goodbye World. So how do we connect these things together? That's where the join operator comes in. So I can just pop inside here again, and I'll give you guys a little explanation of it. All right, so a join operator, it's exactly what it means. Essentially, it's going to join the tables or join records together from different tables when the attributes are related to each other. Okay, so there's an inner join, there's a left join, there's a right join, there's a flutter join, right? These are the basic joins that you're going to be utilizing. Okay, so just to kind of pique your interest a little bit, I'm just going to show you guys what I mean. So remember in our application, we were able to display people's own private data, right? So we're essentially joining data together. And then we logged out and went back into test@gm.com. You can see over here that we also were able to display our own private data. So just to show you guys really quick, what I'm doing right now is if I select all from to-dos and I decide to select all from users, right, it looks very straightforward. We have our two tables, but now we are trying to utilize something known as the join operator. So you don't need to understand this, but I just want you guys to have a little sneak peek before I explain. So I'm going to say select all from users. Okay, so I'm going to select all from users, and now I'm going to use something called inner join. Remember, there's many joins, but in this case, I'm going to use inner join. What I want to be able to do is I want to combine it with the to-dos table. So the to-dos table, and now I have to set a condition of how they're going to connect to each other. So what I'm going to say is whenever the user.user ID is going to equal to the to-dos.user ID. Okay, so look at that really quick. So if you're still a little bit confused, that's perfectly okay. I don't expect you guys to understand this yet. The big idea is that essentially what I'm doing is I'm combining these tables, but only if they reach this condition over here. Okay, so now if I click enter, you're going to notice that I get those three records. So you can see right here that the to-dos data or the to-dos table and the user table were basically put together whenever they had the similar user ID. So you can see that this user ID is similar to this user ID is similar to this user ID, and so on. So pretty neat. But here's the problem though. If you look in our application, you can clearly see that we don't want to display everyone else's to-dos, right? We want to be able to display that person's particular to-do, right? In this case, if we did it this way, then the test was going to be able to see everyone's to-do. It was going to see test number 2. So we want to be specific in what we're showing. So in this case, I just want to simply show hello. So what I can do is I can run the same exact join query over here, and now I can specify a where clause, and I can say where the user.user ID is going to equal to, single quotes, this one right here. So remember, we're focusing on test. We're focusing on test@gmail.com. So I'm going to take their user ID and I'm going to put it right inside here. And then if I click enter, hey, check this out. We only get one record, and it turns out that record is the description of hello. So pretty neat. So this is basically the logic that we utilize. Now, of course, inside my application, I don't use an inner join. I actually use a left join, which I'll explain later. But you can see that the logic is pretty consistent of what we just did inside the command line. All right, so since everything is good to go, let's kind of talk a little bit about inner joins, or sorry, joins in general. All right, so I'm going to take these things all down, and I'm going to move on to here. All right, so a join operator, like I said, is used to combine records from different tables with a related attributes. There's an inner join, there's a left join, there's a right join, and there's a full outer join. right? And I'm going to give you definitions for each one of them, but then I'm going to give you guys examples of how it works. So the thing about a inner join is that it's going to select the records the records that only have matching attributes in both tables. So if you want to think about this, inner join is super strict, and full outer join essentially is the most liberal out of all of them. Next, we have left join, which is now going to select all records on the left table and then all the matchings from the right table. Right, so it's not going to just simply take everything from the right table. It's only going to take the ones that match, but it's also going to continue to take all the data from the left side. Right join is exactly the same thing, except it's on the right side, so it's going to select all records on the right table and matchings from the left table, right? Then we have the full outer join, so the most liberal, which is essentially the combination of the left and right join. And what it's going to do is select all records on the right and left table, even without matching attributes, right? It's going to put them all together. So this is really important because I'm going to show you guys the structure of this type of query. But essentially what we're doing is we're going to select all from users. So this is specifying the left table over here. Then we can define the type of join, so that could either be inner, left, right, or like full join. And then we actually specify the right table. So this can be represented as the left table. This right here is represented as the right table. And then we have a condition that needs to be followed in order to see how they're going to connect to each other. All right, so this may still be a bit confusing, but the next section should make a little bit more sense. All right, so right here I have some fake data. I have the users table, I have todos table. Some of you guys might already catch on that I have a null value for my foreign key, and I know we specified within our database designs that it has to be a 1 to mandatory, but in this case I want to make it clearly shown of the difference between the right and left join. So let's just do it in this situation for now, right? But it's not going to be like that in our application. All right, so if I am doing an inner join, so this is what the query I will run. So it's exactly the same you saw above, except I'm using inner join. What essentially it's going to do is that it's only going to take in the records that have relationship with each other. So you can look inside here that this todos table and this user table over there, they all have similar user IDs, right? They're all connected in some way. So all this data is simply taking all the relationships. So if inner join was a person, they're essentially going to say only couples, right? You can see right there that we have the left to right, which are connected by this user ID together, and then the ones that are single aren't allowed to go inside here because they don't have any relationship. Now let's go on to the left join. So the same exact query, except it's using left join instead. So this is going to look a little bit unique to you guys, but you'll start to notice that you'll see some null values over here. So essentially what is happening is that I'm going to take all the relationships from the left and right sides, and then I'm also going to take in any of the left data, so the rest of the left data that don't have any relationships. So remember, this right here represents the left table, and this right here represents the right table. So essentially I'm taking relationships, and then I'm taking the rest of the users that doesn't have any relationships. So essentially what's happening here is that the left join is saying, I'm only taking in my left people. However, if any of you right people are connected to my left buddies, then you can join too. So you can see here that we have the left people, and then we have the left right that are connected to each other, and the right single people aren't able to join inside. Now the right join is very similar. It's just switched around. And you can see over here that now I switch the todos right tables and I put the users left. Because remember, users right here represents left and todos represents the right side over there. So what's happening is that I am, of course, displaying all the relationships that the todos and users have with each other, but then I'm also displaying the rest of the todos rights without relationships. So you can see here that we have okay, sure, which are represented all null because they don't have any relationships. So the right join is saying that I'm only taking in my right people. However, if any of you lefts are connected to my right buddies, then you can join too. And then of course, like this, we have the single left people who aren't able to join on this side. And of course, we have the most liberal, which is the full outer join, right? Simply using this. And the idea with it is that it's going to be the combination of the right join and the left join. So you can see here that it gets all the relationships based on this condition. But then also you're going to start to notice that it takes the rest of the left without relationships, and it also takes the rest of the todos without relationships. So it takes the left and rights that don't have a relationship with each other. So null, null, and null, null on this side. Right, so basically the the outer join or the full outer join is going to say meh, you know, I'm going to take everyone. And you can clearly see that everyone is inside here now. All right, so hopefully that makes a little bit more sense with the join statements. Now, if you're still a bit confused, that's perfectly okay, because in the next section, we are going to actually start coding this application. So whatever you see over here, we're going to start coding this application, and then we're going to see like how they're going to be able to work inside. All right, so in the next section, we're going to start coding this application. So I'll see you then.